Next, second rule that was followed by the electrons while filling is Hund's rule. Hund's rule when electrons are entering into degenerated orbitals means the orbitals with the same energy are said to be degenerated orbitals. For example, S subenergy level. It has only one orbital. But P subenergy level will have 3 orbitals. D subenergy level will have 5 orbitals. F subenergy level will have 7 orbitals. So they are said to be degenerated. All 7 F orbitals, whether it is 4F or 5F, will have same energy. All 5D orbitals, it may be 3D, 4D, 5D or so on, they have same energy. All P orbitals will have same energy. That means all 3 2p orbitals, all 3 3p orbitals, all 4 4p orbitals. It doesn't mean that 2p and 3p will have same energy. 2p will have different energy and 3p will have another energy. But the orbitals present in 3 orbitals present in 2p orbital will have same energy. And the orbitals present in 3p orbital will have same energy. 4p orbital will have same energy. All the 3 orbitals present in the given cell will have same energy. That's why those orbitals are said to be degenerated orbitals. When electrons are enter into degenerated orbitals, the pairing of electron will take place only when all degenerated orbitals are filled with 1 electron each. When electrons are enter into the degenerated orbitals, the pairing of electron will take place only when all degenerated orbitals are filled with 1 electron each. Pairing, what is pairing? We have already discussed in spin quantum value. Each orbital can accommodate 2 electrons. 1 electron will spin in clockwise direction and other electron will spin in anti-clockwise direction. So there is a place for 2 electrons in an orbital. So the second electron will enter into that orbital only when all other same energy orbitals are filled with 1 electron each. Then only the pairing will take place. For example, in S subenergy level you have only 1 orbital, so first electron will enter here and the second electron will like this. That means pairing will happen or occurred with the second electron itself. But in the case of P subenergy level, first electron will enter here, okay, then second electron is there. Now according to our opinion, this orbital can accommodate second electron, but there are 2 more orbitals with same energy. So the second electron is not possible to pair with the first electron because these orbitals are empty. So the second electron will enter here. Though there is a place for 1 electron, 1 more electron here, the pairing will not occur just like S orbital because of these available orbitals with same energy. So the pairing is possible only when all these orbitals are filled. That means when 3 orbitals are filled with 1 electron, then 4th electron will pair up here. That means in P subenergy level, pairing will take place from fourth electron. It is not possible for a second electron to pair with first electron. Similarly, in d sub-energy level, the pairing is possible after filling up of all these 5 orbitals. That means the pairing in d sub-energy level is possible with the 6th electron only. Similarly, the pairing in f sub-energy level is possible only with 8th electron only. This is Hund's rule. Hund's rule says us that the pairing of electrons takes place only when all degenerated orbitals are filled with 1 electron each. Suppose in any atom, if electronic configuration is represented like this, that is against to Hund's rule. That is against to Hund's rule. The pairing should not be takes place when 2 orbitals are empty. When 2 degenerated orbitals are empty, the pairing should not take place. Suppose in some other atom, if electron configuration is represented like this, so this is against to Aufbau principle. Because the electron will enter into this orbital only when this orbital is completely filled. So this configuration is against Aufbau principle, and the previous configuration, this is against to Hund's rule. Violation may be according to any rule, but you should be in a position to identify which rule was violated. Here, before filling this s orbital, electron is entering into the next p orbital. This is against Aufbau principle. Here, before filling these 2 orbitals, the pairing takes place here. So this is against Hund's rule. After filling of this orbital only, the electron is supposed to enter into this orbital. When enter into this orbital, the pairing is possible when all degenerated orbitals are filled with 1 electron each. So, these are the Hund's rule. Hund's rule means when electrons are filling in degenerated orbitals. Degenerated orbitals means the orbitals with same energy. 3p orbitals in a p sub-energy level. 5d orbitals in a given d energy level. 7f orbitals in a given f sub-energy level will have same energy. That's why they are called as degenerated orbitals. When electrons enter into these degenerated orbitals, the pairing of electron is possible only when all degenerated orbitals are filled with 1 electron each. Pauli's principle. Pauli's principle explains us that no 2 electrons in an atom will have same set of 4 quantum values. No 2 electrons in an atom will have a same set of 4 quantum numbers. 4 quantum numbers means n value, l value, m value, and s value. We have already discussed that these quantum numbers are just like our address. Just like our address. Suppose in your class there are 40 students. No 2 students will have same address. Because in your address, what is the details that were given in your address? Your name, your father's name, your house number, town, street, district, state, country. This is your address. So no 2 persons in this world, no 2 persons, not only in your class, no persons, 2 persons in this world will have same address. Your names may be same. Sometimes you may have same names. Krishna, Krishna, Rama, Rama, Ramesh, Ramesh, Gopal, Gopal, and so on. Your names are same. But in your address, your father's names are different. Your father's names are different. Your father name may be someone, and other father, your father name may be different. Accidentally, if your father's names are also same, that may be an accident. Or sometimes it may be possible. Then the house numbers will differ. You will have one house number and you will have another house number. By fault or default, your house numbers are same, because two different towns may have same type of house numbers. Then in such cases, your town name may be changed. Though you suppose accidentally in two states, same two towns are there with same name, then state name may be changed. For accidentally, in two different countries, the same states, same districts are there. Same towns are there. Town names may be also, same states are there in different countries. Then country names are changed. So definitely there will be a difference in any one of those information. No two persons in this world will have same address. Just like these quantum numbers are nothing but an address to an electron. So no two electrons in an atom will have same set of 4 quantum numbers. For example, if you take uranium atom, in uranium atom you have 92 electrons. If you go on writing all 4 quantum numbers to 92 electrons, you will get 92 different combinations. You never get same set of 4 quantum numbers for 2 electrons out of these 92. Sometimes n value may be same. In such cases, L value will be changed. If n and L are same, ms value will be changed. Or n and ms values may be same, L value will be changed. N, L, m and m values are same, automatically spin quantum value will be changed. Let us see how it is possible. We have this is 1s orbital. In 1s orbital, you have 2 electrons are possibly filled in this orbital. Now let us write all values, possible values for these 2 electrons. For this electron, this is for this electron, and these are the for this electron. N value, n is equal to 1. For this also, n is equal to 1. L is equal to 0. For this electron, L is equal to 0. M value for this electron is 0. For this also 0. For spin value, S is equal to plus half. Automatically for this it is minus half. For these 2 electrons, N value is same, L value is same, M value is same, but spin quantum value is different. That means there is possibility to have same 3 quantum numbers, maximum 3 quantum numbers may be same. Definitely the 4th one should differ. It means when 2 electrons are there in one orbital, they must be in opposite spins. When 2 electrons are there in an orbital, the orbital will have same set of 3 quantum numbers. For a given orbital, all 3 quantum numbers are same. So according to Pauli's principle, the 4th quantum should differ. That means 2 electrons in an orbital must be in opposite spin. That is given by Pauli's exclusive principle. No 2 electrons in an atom will have same set of 4 quantum numbers. Okay, now let us verify another example. Now this is the electronic configuration of carbon. 1s2, 2s2, 2p2. Now choose any 2 electrons in this atom and let us write down the 4 quantum values. Okay, let us take this one and this one. Now wait, let us compare for these 2 electrons. Now let us write n value. For this electron, n is equal to 1. For this electron, n is equal to 2 because it is 2p. Now for this electron, L is equal to 0. For this electron, L is equal to 1 because it is p. For this electron, M is equal to 0. For this electron, M is equal to minus 1. For this electron, S is equal to plus 1 by 2. For this electron, spin quantum is plus 1 by 2. Here, spin quantum may be same, but the remaining quantum numbers are differed. You may have doubt. Let us compare with this. Let us write for this electron, n is equal to 2, L is equal to 0, M is equal to 0, S is equal to half. So for these, if you compare these 2 electrons, L value is same, M value is same, S value is same, but N value for this electron is 2 and for this 1 and for this electron it is 2. You may compare any 2 electrons of atom. They will have a specific set of 4 quantum values and no 2 electrons will have same set of 4 quantum values. No 2 electrons in an atom will have same set of 4 quantum values. This is Pauli's exclusive principle. Electronic configuration may be represented by 2 ways. One is NLX method. NLX method. N stands for principal quantum value, L stands for that angular momentum quantum value, and X stands for the number of electrons present in that quantum. For example, hydrogen, its atomic number is 1. Its atomic number is 1. So, the electronic configuration of hydrogen can be represented as 1s1. 1 is N, S is L, 1 is X. That means this electron was present in S subenergy level of first orbit. 1 electron is there. So it is said to be 1s1. Now this electronic configuration can also be represented with boxes and arrows. So this s orbital can be represented with one box like this, and this electron will be represented like this. Boxes and arrows method. These are the 2 methods. One, this is NLX method and this is boxes and arrows method. Now let us take helium. Helium's atomic number is 2. So electronic configuration is 1s2. That means in first energy level, S suborbital, you have 2 electrons, one with clockwise spin and other with anti-clockwise spin. Similarly, lithium, atomic number is 3. So its electronic configuration is 1s2, 2s1. And it can be represented like this. 1s2, 2 electrons are there. 2s1, 1 electron like this. Beryllium, one s2, 2s2, like this. The sum in these powers is equal to atomic number. So 1s2, 2s2. Next, boron. Atomic number is 5. Its electronic configuration can be written as 1s2, 2s2, 2p1. 2 plus 2, 4, 4 plus 1, 5. And it can be represented like this. Then carbon. One s2, 2s2, 2p2. Now here first electron enter here. There is a place for second electron also, but according to Hund's rule, this electron will enter into this orbital. Like that. Nitrogen, atomic number is 7. So its electronic configuration is 1s2, 2s2, 2p3, 1s2, 2s2, 2p3. Oxygen, 1s2, 2s2, 2p4. 4 plus 2, 6, 6 plus 2, 8. Atomic number is 8. Here the pairing will take place. Fluorine, 1s2, 2s2, 2p5. Next, neon. One s2, 2s2, 2p6. Sodium, electronic configuration is 1s2, 2s2, 2p6, 3s1. So because up to this electronic configuration will become to neon configuration. So this electronic configuration can also be represented like this. Neon, because up to this it is neon configuration. So it can be represented like this also, 3s1. Then magnesium, So up to neon, same configuration, that is 10 electrons. So first 10 electrons of magnesium will have same arrangement just like neon. So we can represent like this, neon. Neon means 1s2, 2s2, 2p6. Then 3s2. Aluminium. Up to neon, first 10 electrons will have same neon configuration, 1s2, 2s2, 2p6. Then 11th electron onwards, it have different configuration, 3s2, 3p1. Silicon, atomic number is 14. Here also first 10 electron just like neon. Sorry, 3p2. Then phosphorus. Three S2, 3p3. In S suborbital we have 2 electrons, and P we have 3 electrons. Then sulfur. Atomic number is 16. So first 10 electrons are just like neon. Then rest electrons are 3s2, 3p4. Then chlorine. First 10 electrons are just like neon. Argon. First 10 electrons are just like neon. 3s2, 3p6. So with argon, the third energy level s and p orbitals are completely filled. Now in third energy level, we have 3d orbital and 4s orbital. So in 3d orbital, here we have potassium, atomic number is 19. First 18 electron will arrange just like the 18 electrons that were arranged in argon. Now the 19th electron, where it has to enter. In third energy level, we have 3d orbital, and next orbital is 4s. Now let us verify the n plus L value of these two atoms. For 3d orbital, n plus L value is 3 plus 2 is 5. For 4s, it is 4 plus 0 is equal to 4. Out of 3d and 4s, the n plus L value of 4s is less than 3d. That's why the electrons will first enter into 4s orbital rather than 3d orbital. So in potassium, the first 18 electrons will arrange just like the 18 electrons of argon. That is 1s2, 2s2, 2p6. This is neon. Then 3s2, 3p6 up to argon. And the 19th electron will enter into 4s1. Though there is d orbital in third energy level, its n plus L value is more than 4s. That's why the electron will enter into 4s instead of 3d. So in potassium, the electronic configuration will be argon. Up to this is argon configuration, and 4s1. Now, after potassium, we have calcium, 20. So, argon 4s2, because 4s orbital can accommodate 2 electrons. Now, after calcium, the next element is scandium. Scandium atomic number is 21. So, where it has to go? After 4s we have 4p. After 4s we have 4p. But in the third energy level we have 3d orbital, which is also empty. Let us verify the n plus L value of these two. For 3d orbital, n plus L value is 3 plus 2, that is 5. Because L value for d orbital is 2 and this is 3. For p orbital, L value is 1 and n value is 1, 4. That's why 4 plus 1 is equal to 5. So, 4s orbital is filled. Next to 4s we have 4p orbital. But previously there is an empty 3d orbital. The n plus L value of these two are same. So, if two orbitals with same available, the electron will enter into the orbital with the least n value, that is 3d. Because 3d n value is 3, whereas 4p n value is 4. So 3d should be filled first. Then, so in scandium, up to argon, 18 electrons or electronic configuration is same. The next two electrons will enter into 4s2 and 21st electron will enter into 4d1. And in the next 10 elements, the d orbital will gradually fill up. That is electronic configuration. Scandium, titanium, so that titanium Z is equal to 22. Argon 4s2, 4d2. Vanadium 23. Argon 4s2, 4d3.